Hi, good morning. I am Devi Abhirami, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. Today I am going to explain the topic in the discrete mathematics with probability and hypothesis testing, and my topic is test of hypothesis for large samples. In the previous video we have seen the small sample test by using an Z test and T test. By using the hypothesis test we conclude our solution. So here also I am going to solve the problem, and my problem is two machine learning models but trained on the same data set. There are two types of a model, that is model X and model Y. The problem is concluded by a below table, and the sample size of two models are 1024 and 900. Some mean accuracy is 92.3 and 91.5. Standard deviation for model X is 3.8 and the standard deviation of model Y is 4.1. So we have to test the significance of an two hypothesis by using a two test formula. Two test formula is x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2. Okay, we know all the values of this problem, and if I solve it we will get the answer as 4.42. okay, they have mentioned that the level of significance is 1%. 1% means the level of significance is 0.01. At 0.01 is 1.94, which is very greater when compared to our problem. So the model X has significantly higher mean than the model Y. Okay. My second problem is an e-commerce company runs a promotion in two regions. One region is East 2500 orders and other one is West 2200 orders. There are 300 different orders. Average order value is 78.40 and the average order value for the region West is 81.20. Standard deviation is 22 and 23 for the two types of regions. They have given that the 1% level of significance. So I am going to test with an Z of two different means. So my formula is x1 bar minus x2 bar divided by s1 square by n1 divided plus s2 square by n2 square root of. So East and West, there are two types of a model. So East is n is equal to 2500 and 2200, and the mean value is 78.40 and 81.20. We know all those values, and we can substitute those values in our formula. If we substitute it, we will get our numerator as minus 2.80 and my third denominator value is 0.586589. If I divided it, I will get the value as minus 4.25. It is obvious that some of the problem will have a negative solution also. It is, as it was a two-tailed test, it has a level of significance value is 2.576. When compared to my value, it is very greater, so we can reject our null hypothesis. There is a strong statistical evidence, that is there is a significant difference between the two regions, that is the East region is different from the West region. So the higher order value in the West region. From those hypothesis tests, we can conclude that the West region has a large hypothesis. Okay. And our third problem is an online advertisement team is running an A/B test for a performance. There are two products, red and blue. Red has a sample size of 5000 and the mean value is 4.82, whereas the standard deviation is 2.1% for the red control. For the blue new model, 4800 sample size, mean value is 5.31% and the standard deviation is 2.3%. So I am going to perform a Z test for a 5% level of significance. So we know the formula is x1 bar x2 bar divided by square root of s1 square by n1 plus s2 square divided by n2 square. Okay. So the hypothesis, there are two types of hypothesis I am going to define here. The null hypothesis, if it is less than or equal to, then we can conclude that the null hypothesis is accepted. If not, we can go with an alternate hypothesis. Alternate hypothesis is nothing but the blue model is greater than the red model. Okay. So by using my formula xb is nothing but the blue model and R is nothing but the red model. So my denominator value and the numerator value is calculated separately to calculate the standard error value also. By calculating the value, approximate answer is 10.99, whereas my significant level is 1.645. While comparing those two values, it is very less, that is our table value is very greater. If it is greater, we assume that the alternate hypothesis is accepted. So if the alternate hypothesis is accepted, we can conclude that if the alternate hypothesis is accepted, we can conclude that the null hypothesis is rejected. Sometimes it may happen. So for this kind of cases, we can conclude that the null hypothesis is rejected and the alternate hypothesis is accepted. So from this conclusion, I conclude that extremely large Z value and the strong statistical significance, that the team should roll out the blue ad copy to the full audience to improve their marketing fee. So this is how we have calculated the hypothesis test. Thank you.